that are used to create containers, that are used to manage containers. For example, on my screen, we can see that we are going to talk about pods, controllers, services, volumes, config map and secrets, deployment and stateful set. Start with the very first resource, that is pods here. Pod in a Kubernetes is the basic building block, the basic unit that the Kubernetes cluster handles. Like when I want to create a container, that container will be created within a pod, and Kubernetes manages the pods. Kubernetes is a tool, it's an orchestrator that manages containers. Like we have Docker Swarm. Docker Swarm manages Docker containers. Similar to that, Kubernetes manages containers. And Kubernetes is one of the open source orchestrator used for many kind of applications that you want to containerize. So the first and the basic resource in Kubernetes that we always create is a pod, which is the building block of Kubernetes. And we can deploy multiple containers in a pod. We can have a multi-container pod. The main purpose of this is to reduce the coupling. We want to decouple the containers. Means I want to decouple Kubernetes from managing containers directly. To reduce that, decouple those things, we put the containers within the pods. Now you can use any container within a pod. It can be a Docker container you can use in Kubernetes. It can be CRI-O container. It can be container D, or it can be LXC container. So you can use any container tool with Kubernetes. We can also deploy a multi-container pod. Along with that, multi-container pods will be sharing the same user space, same network space, because they are in a same pod. Pod is the basic building unit of Kubernetes. Like for a Docker, what is the basic building block? A container. A Docker manages the containers directly. The Kubernetes manages pods. And in the pods, we create containers. Let's talk about our next resource, which is controllers. So what a controller is? A controller is basically a manager that manages the life cycle of the pod. The controllers are nothing but your control loops that are continuously monitoring the state of your pods through your API server. Kubernetes has an API, and controller manager is watching the state of your pod. Let's suppose if the pod dies, like in Docker Swarm, we were doing it up. I was deleting a container and that container was auto creating. How it was happening? It was happening via the controller. Docker Swarm also, you have some controllers that are managing it up. If let's suppose here, if a pod dies out, controller is watching, it is monitoring the state of those pods. And how it is monitoring? Via the API. Controller manager talks to the API to see the state of the cluster. And if it finds that the cluster is not in a desired state, for example, I want my application to run in 2 pods. In such a case, if one of the pod dies and if one of the pod is running, my cluster is not in a desired state. I want replica count 2, but I'm only running replica 1. So controller is going to create the new pod for me. That is what a self-healing architecture provided by Kubernetes. You can also call it as a fault tolerance nature of Kubernetes. It will always maintain and bring the cluster to the desired state. But yes, all of them are being controlled by a single binary, that is controller manager. And we have different types of controllers like deployment, stateful set, daemon set, replication controller, replica set. So these are different controllers in Kubernetes, and every controller has a different use case. We are going to talk about is services. So service is a component that is used to expose the pods to the outside world. For example, in a Docker Swarm cluster, what I was doing, I was using a port advertisement. I use a flag -p. That -p is for advertising a port. Same thing in Kubernetes. Like I have a pod. Inside that pod, I am running a container. Now that container needs to be accessed by the outside world. In order to do that, what I want here is I need to create up a service. That service exposes my container application to the outside world. That is what services do. So services add up a layer of extraction over the pods. The services defines a policy which the pods are using access, and services load balance the request between the pods. Like I have 3 pods and I'm created a one service. When I will send my request to that service to access the pod, the service will be sending that request, that input request, to any of the 3 underlying pods. That is what services are meant for. we are going to talk about is volumes. Like Docker volumes are mainly used for storing the data. Same way in Kubernetes also we have the volumes here, and volumes here are ephemeral. It can be persistent, it can be non-persistent. So ephemeral volumes are those volumes if your containers is lost, data is also lost. Containers are also ephemeral. Like whatever data you put in a container, in a pod, that will be lost if the pod is deleted. Same with the Docker container. In the container, you put some files and you delete the container, you recreate the container. Those files that you created in the container will not be visible in the new container. That is what we call as containers are ephemeral. Now to make the data persist, we require volume. So volume provides storage structure which is attached to a pod to store the data. And life cycle of a volume be bound to a pod. Like it can be, it cannot be. For example, if a pod is running, I attach a volume to the pod. Pod is storing data on that volume. Now, if the pod dies, I can make sure that the volume also dies. But I can also do the vice versa. If the pod dies, I will make sure that the volume will still remain intact. My data should be still kept safe. Now, when the new pod will get created, the volume will be attached to the pod again, and we will be having the same old data. So that is also can be done. Volume helps us in restoring the containers to the previous state. It helps us in bringing all the data back. That is why we use Kubernetes volumes to store data. Next is we are going to talk about config maps and secret. So config map and secrets are nothing but to store any kind of configuration information or any kind of secret information. Secrets are mainly your confidential data, your sensitive data. You don't want to expose to the outside world. Means you don't want to keep it in a plain text format. You want to use the password, but to pass that password, you don't want to pass it in a plain text format. How you can manage your confidential data in Kubernetes? In order to manage that, we have a resource called as secret. And config map is for non-confidential data. Any kind of configurational data. For example, username, port numbers, IP address. This is some configurational data about the application. To manage all this non-confidential data, we require config maps. Config maps for non-confidential data and secrets for the confidential data. To manage such kind of data, we require these resources in Kubernetes. And next, now we are going to talk about deployment. So deployment again is a controller, and this controller is mainly used to manage the replica of the pod. Like we have seen controller. After pods, we have discussed about controller. What a controller is? Controller is a control loop that maintains the state of a cluster. It sees the state of the cluster via the Kubernetes API and manages it up. Deployment is a type of a controller that is going to maintain the minimum number of replica of the pods. Like let's suppose I want to create an application with 3 replicas. In such a scenario, I will be using a deployment, and that deployment will manage those 3 replicas of the pods of my containers. Containers run within the pods. So I will be managing pods here. Now let's suppose out of 3 pods, 1 pod is dead. So deployment is a controller that will allow me, that will automatically create the 3rd pod. I have 3 pods. I have set deployment to go with 3 pods. If one of the pod is dead, deployment will go and recreate the 3rd pod again. It has to maintain that desired state of 3 pods. It allows us to do rolling updates and rollbacks. That is what deployment do. So this is what deployment is, a controller. And the last thing that we have is a stateful set. Again, a controller that manages the pod, but this is mainly used for stateful applications. Now, this stateful set, again, it's a controller only that manages the desired state of the cluster. But this stateful set is used for those applications which are stateful in nature. Now, what does that mean, stateful? Stateful simply means one thing, the application for which data is important. Like if you lose the data, the application will be down. Those applications are called as stateful applications. For example, any database, SQL database, Oracle database, Postgres SQL database. For the database, if you lose the data, tables, databases, you cannot run that in production, means you're out of production. If you lose the database, you have to recover everything. So such kind of application where data is important is called as stateful application. An application for which data is of least importance, like a caching application. GUI don't hold any data. You create a web server. A web server don't have any data. Fetching the data from the database. Such kind of application which is not holding any data. Or even if you lose the data, you're good to go, means you can recreate the application and start again, like a caching application. So such kind of application are called as stateless applications, for which data is very least important. And how we manage these stateful applications in Kubernetes is via stateful set. Uniqueness of the pods. You have pods with unique names, you have a pod with unique network identity, you have a pod with unique storage, and it basically requires a headless service. A service is required to expose these stateful set pods to provide the network identity to the pod. I told you it requires three things: a uniqueness of each pod, unique name, unique network identity, and ordered provisioning. These are the three important features of a stateful set. And this is only a controller that manages these stateful applications. There's a command line tool that is used to interact with the cluster, that is used to manage the complete cluster. For example, running a Docker command, I was using a command called as docker run. For deleting it, docker rm. All these commands were Docker commands. For that, I require a Docker CLI, and that Docker CLI was managing my Docker daemon. Same thing in Kubernetes. I also need to talk to my Kubernetes cluster here. And for talking to my Kubernetes cluster, for managing my Kubernetes cluster, I require a command line tool. And that command line tool in Kubernetes is called as kubectl, or you also call it as kubectl. That is the command line interface to interact with the cluster. It takes all its configuration from its .kube directory. We will see this directory .kube today, like from where it is taking up all the configurations. And kubectl always interacts with the API server to manage the cluster. So Kubernetes has a component called as Kubernetes API, which runs on the manager. Like in Docker, you have a manager. In Kubernetes, we call the same node as a master node. We also have a master worker configuration here. Like in Docker Swarm, we had manager and the worker. Similar thing in Kubernetes, master worker. So the API runs on the master nodes, and we execute all commands, interacts with the API, and API runs on the master to manage my cluster. kubectl, it cannot be used to create a cluster, but it is used to interact with a cluster. It is mainly used for interacting, for bootstrapping, for creating a cluster, for destroying a cluster. We use another utility called as kubeadm. That's another tool, that's another CLI. But for interacting with the cluster, for creating any resource in the cluster, we will be using kubectl. So let's start here with some commands here. Let's see some commands: create command, get command, run command, expose, delete, apply, and edit command. Let's see all these commands. So what these commands actually do here: create command first of all. So create command is a command that is used to create any resource in Kubernetes. So I will be writing up a YAML file. In that YAML file, if I want to execute that YAML file, I will be using a command called as kubectl create command, and I will give -f flag, and I will specify the file name to create a pod. We will see this in the demo, how we use the create command. If you want to get any resource, if I want to get any resource, I will be running the kubectl get command, like any resource that you want to list. For example, I want to list the pods. I will be running a command kubectl get pods. That will give me the list of all the pods that I'm running. Get command is used to display the resources that are running in the cluster. Run command is mainly used to run any resource in the cluster. Like we use docker run command to run a container. Similar command kubectl run command to run a pod in the cluster. Kubectl run command is used to directly deploy a pod in the Kubernetes cluster. That is what we use, run command. Then we have the expose command. Expose command, this command is mainly used to expose a service, to create a service, to expose anything. Two resources can talk to each other. Like I want to create a service. What a service is? A service in Kubernetes is a resource that is used to expose. I'll be using a command called as kubectl expose. Then we have the delete command. Delete command is used to delete everything. Like for example, I want to delete it. In Docker, it was docker rm command. Here we have the command kubectl delete. And if you have a JSON file or any file, you can execute it via the file as well. So kubectl delete -f, and you give the file name. That is what we do here. Then we have the apply command. Apply command is mainly used for applying any configuration in the YAML file. Like I have a YAML file and I want to apply something. It is already running. So if I make any changes in the YAML file and I want to apply that to a pod. And finally, we have the edit command. Edit command is the command that is mainly used to edit a resource. Let's suppose it is already running. I want to edit it. So I can simply run the command kubectl edit. I can give the file name or I can also give the resource name directly, which resource you want to edit. And edit command only works with sources that are already running in your cluster. Let's see a small demo around this. Let me take you to one of my Kubernetes node here. So this is my Kubernetes cluster. You can see that I'm running 2-node cluster, kubectl get the nodes, how many nodes I have. So I have a 2-node cluster. One is a master node, the other one is a worker node. I have just a 2-node cluster, and see the version that I'm running the version 1.23. Role is control pane master. This is the master. Master, similar node like in Docker Swarm, you have a manager and a worker. Same way in Kubernetes, we call it as a master and the worker. And that is what we have here. That node is called as the master node. And worker node is the node where the pods will get created. So I have that worker node also with me. You can see this is my worker node. And this is my master node. Start creating some pods. So let's execute the first command, the run command. kubectl, I want to run a pod. Right now, let's see if I have anything. So how to list anything? Command is get. I want to get the pod. Let's go and execute it up. So how to execute? Command is kubectl run, and you give a pod name. For example, I give the pod name as my first pod, and I give the container that I want to execute in this pod. So kubectl run, give the pod name. After that, the image of the container that you want to execute in this pod. Now, once you hit enter, you will see that the pod is created. This is any user defined name. But yes, the container image, you can use your relevant container image, HTTPD, Nginx database, any image you can use it. So now let's see kubectl get the pod and 1 by 1. What this 1 by 1 actually means here is, this 1 by 1 simply means that this is the total number of containers a pod has, and this is the number of containers that are running in the pod. Now you can also see output something called as 2 by 2. 2 by 2 means the pod has total 2 containers and out of that both are running. Let's see a command to check it out. Let's see if it is running or not. So the simple command to do that is kubectl describe the pod. I want to describe the pod and the pod name is my first pod. So if you see a describe, see it says this is my pod guys here, and this is the IP address of the pod. Inside the pod I'm running a container, and this is the image of the container. It is pulled from Docker Hub, Docker pullable. See this, it's a container. Let's see the events to understand it more. Event says successfully assign the pod to worker. So this pod is assigned to the worker node. I have 2-node cluster, we have checked it. So I told you again, similar to Docker Swarm, where you will be running the API and all the commands from here master, or the actual container will be created on the worker node. After that, I pulled the image HTTPD, successfully pulled the image in 6.2 seconds, created the container, started the container. So here my pod name and container name is same. Inside the pod, I'm creating up a container, but I can also differentiate them by using a YAML file. Let's see how we delete this pod. So kubectl get the pod. I want to delete this pod. You can also give pod pod, or short form for pod is po. I can use anything, like you can use pod or po, one and the same thing. It will give you the same output. So I've deleted the pod. Now let's see the pod kubectl get po. It will give you the pod. See no resource found in default namespace because the pod is deleted. Now let's try to create it from a YAML file. My pod.yaml, I give a name here. I open a file here and I edit this file. So first of all, I have to write the API version to which API pod belongs to. And how we can know which API version pod belongs to? You can run the command kubectl explain command. Okay, so this will explain you the pod. See, the kind is pod, version is v1. So I have to take these two fields to write in the YAML file. And if you want to see more details about pod, you can read these, what these things are. But this is what I need to do. kubectl explain the pod to me. Here you see the version and here you see the kind. So let me go and write a YAML file vi mypod.yaml. The kind is pod. Guys, it is case sensitive. It always starts with a lower case, but version V should be capital. Pod P should be capital. There must be a colon with a space. So it is always case sensitive. This is kind. Kind is pod. API version is V1. P capital. After that, what is the metadata of the pod? Metadata simply means that what is the data about the pod? Data about the pod means simple thing. I have to use indentation so that I can put that under metadata. What is the name of the pod? Metadata means some data about the pod. After that, I have to give the specifications of the pod, spec section. So normally every YAML file in Kubernetes has 4 sections. One is the API version, kind, metadata, and spec. Metadata contains the data about the resource that you are creating, and specification contains its specifications. I am going to create containers here. Let's suppose, and container is an array. It will have multiple attributes. So it will start with a minus sign, because a container has lot many attributes, name, image, port, lot many things it will have. So that's why we call, in YAML file, we call it as an array. So that's why container is an array. I'm starting with a minus sign. What is going to be the name of my container? My name of my container is, let's suppose I give first container. I give first con here. What is the image for this container? I give an image for this container. Let's suppose I want to use HTTPD application. Now I can execute this. Let me create one more container inside the pod. Let's have a pod with 2 containers. I use this as second container, and after that I give the image for that. Let's suppose I give the image as Redis. That is a small database that we can create. So I'm creating in one single pod, I'm creating 2 containers, first container, second container. Let's save and quit this file. So now you can see my file here, cat mypod.yaml. See, this is the file. And if I want to execute this file, I'm going to use the kubectl command, but with kubectl command, I'm going to hit create. This is the command, and I have to give a file name -f. -f, the file name is pod.yaml. This is the command to create a pod. Kubectl run command, or if you want to go with some multi-containers pod, you want to make some customizations, like I want to change the container name, I want to give a different pod name, different container name, I want to use multiple images here for different containers. So in that case, I always use this YAML file. I write this YAML file and I will be executing it with the kubectl command. You hit enter and you see it is created. Let's see, kubectl get the pod. So it is saying pod 0 by 2 containers getting created. 0 by 2 means it has total 2 containers, out of which 0 are running. Let's see the output again. And now you see 2 by 2. 2 by 2 and the pod is running. 2 by 2 simply means it has total 2. The first 2 says how many containers are running. The second 2 will say you how many total containers are there in the pod. Let's see a describe on this. So kubectl describe the pod, and I run the command my pod. Run the describe command on this, and you see here, let's see, this is the pod name here, my pod, and pod has 2 containers, first container and second container. First container is HTTPD, second container is Redis. See, it has 2 containers. This is second container, this is first container. And you see the event, successfully assigned pod to the worker node, pulling image HTTPD, successfully pulled image in 1.19 seconds, created container, first container, started container, first container. Pulling image Redis, successfully pulled image Redis in 2.77 seconds, created container, second container, started container, second container. So this is how we have created the pod. My pod is all running. kubectl get the pod. Now I want to delete this. To delete this, command is very simple. If you want to edit something in this pod, you can use the command edit. We'll see this command at a later stage. So kubectl edit the pod. And if I want to edit something, I give the pod name my pod. Okay, now this is the complete YAML file. Whatever you want to edit here, you can edit it up here. I want to create a label on this pod. Right now, let's see if I have any labels here. So kubectl get pod -- show minus labels. What a label is? Label is just a tag on the pod, a tag to identify. So right now, don't have any label. Let's suppose I want to create a label. I can run this command, kubectl edit the pod, and I give this pod name my pod. And in this metadata, I give a label here. Simply save and quit. It opens the file in the VI editor. It says it is edited. Let's see if it is edited or not. So kubectl get pod minus minus show labels. You see it is labeled. Earlier there was no label, none. I want to edit this. So what I did, I edited the pod. Like you can see it again. I edit the pod again, and this labels, I've added the label where under metadata, because this is the data about the pod. This is just a tag on the pod. That a label is that this pod belongs to production environment. Environment is production. And I save and quit, means you can do that, save and quit here. Right now I'm not making any changes, so it says no changes made, but I made the change already. You can see it up here, environment equal to production. Earlier it was showing none. After making the change, it is showing you this. Now let's go and delete this up. So to delete this up, command is very simple, kubectl delete, and I want to delete the pod. I can give the pod my pod. This is one way to delete. The other way to delete here is kubectl delete command minus f and give the file name, the file that was used to create the pod. This was the file that was used to create the pod. The same file, what was my create command, kubectl create minus f my pod.yaml. The same command, instead of create, I'm going to use delete here, and this will delete the pod for me. Kubectl delete, and I hit enter. You will see it is deleted. See my pod deleted. Can I see any pod? Kubectl get the pod. We have seen the creation, we have seen delete command, we have seen the run command, we have seen the edit command. Along with that, we have seen the get command. All these commands we have talked about here. Now let's see about some more commands in Kubernetes. Let's talk about these. These are some basic commands that we use day in and day out. So we have talked about create, get, run, delete, edit. All these commands we have talked about here. Now let's talk about some other useful Kubernetes commands. So some other useful Kubernetes commands that you can see on the screen is a label command. I created the label by running kubectl edit. I created a label on the pod. I can do it without editing also. I can do it by running a command called as kubectl label. So kubectl label command is used to label the pods or any resource in Kubernetes. Label simply means a tag. A tag means the identity of a pod. I have another command called as kubectl scale command. Scale command means, let's suppose I just created one pod. I want to scale it up to multiple numbers. Like I want to have 2, 3, 4, 5 pods. I just have one pod. I want to scale it up. So how I can scale it up? It is using kubectl scale command.